Nou, ik zet hem hier. Jos, heb je deze nodig? Heb je die nodig?
Maar 5 woordjes. Dankjewel.
Dat dacht ik al. Ik kan hem mijne gewoon dichtklappen en dan jou er bovenop zetten. Is het? Other side. It's on the other side, right? Yeah, take it out of the... That'll work.
Hello, everybody. Hello. Oh, nice to meet you all. Hello. What are your lovely faces? Anyway, we're having a lovely meetup tonight. Thank you for coming, as you see on this big screen. And we'd like to thank our lovely partners at Developers.nl. Andy Muller, who is behind here. Very popular person. Look at the shirt. Wow. And all of our other friends from Developers.nl. I can't name them all. There's so many of you. Anyway, we have a conference coming up in September called React Live. It's about React.js. Some of you were interested in it. Apparently, Gert will do a talk about some open source components. Very exciting. Anyway,
I guess so.
We're providing a discount just for you all. I know this sounds like a sales thing. We sold like 35% in the first 3 weeks, I think. So we've got about 600 tickets to go, and we think that we sold out in the next month or so. So if you want to go, feel free to use this discount code. Go to our website, reactlive.nl. We're going to have 15 speakers speaking about lots of the new updates in React. We're probably going to have 2 of the React core team members there alongside a lot of industry leaders and some other cool people, so I think you'll love it. Anyway, the first speaker will be Gert, here, as I mentioned.
Haven't done anything yet.
And the second speaker will be Pieter van Dorst, speaking about web components with a little bit of React.js. And that was everything we had for you. Okay, well thank you. I hope you enjoy the night. And thank you again to our sponsors, Developers.nl.
All right, thanks. I need the dongle for it. A little bit of setup. So I have this microphone here, but it's not for the speakers, it's for the recording, in case you're wondering. Cool. Right. So, thank you for coming. I'm Gert, and I'm going to tell you all about how to publish an open source React component. So, like I said, my name is Gert Hengeveld. I'm a consultant with Xebia. Xebia is a Dutch IT consultancy firm. We do all kinds of stuff. I'm mostly focused on software development, full-stack software development. And actually, this week is my last week at Xebia. Because as of next week, I'm a software engineer for Chroma. And you might know Chroma for Storybook. It's the company behind Storybook. Norbert de Langen, one of my former colleagues from Xebia, is going to be my colleague again. So I'm joining Chroma as of next week, which is an exciting step for me. So this talk is not about React Async, but it is, in a sense. React Async is a React component. It's a library that I started developing a little over a year ago, released it on GitHub, published it on NPM, did a lot of work, a lot of investment into it, presented about that at several meetups and conferences. You've heard of it, maybe you haven't. This talk is not about what React Async is or does. You can check out the website, reactasync.com or .dev. It's also on my t-shirt. This presentation is about everything that I had to figure out and do while building React Async and trying to publish it in a proper way on GitHub, on NPM, promoting it, making sure that it works properly, and everything surrounding that entire process. So React Async is basically a one-man team. There is some pull requests coming in every now and then, but in essence, I'm the guy running the whole thing. But that's fine, because React Async is a fairly small thing. It's a niche project focusing on making, working with HTTP requests in React easier and nicer. But as you might be well aware, writing JavaScript code, it's complicated. And that's only the start when you're building a library. Testing JavaScript code is also complicated. And then publishing that code onto GitHub, onto NPM, is also complicated. It's harder than it looks. And then finally, once the thing is out there, you need to maintain it. That's also complicated. So there's quite a few things involved here. So let me tell you a little bit about React Async. React Async is a project that doesn't just consist of one component. It's actually, the main component is the async component in React. You might know a little bit about React. It's all about components. Async, that thing, was the first component that I initially published and kind of took off. And later on, I added subcomponents to make it easier to work with it in specific scenarios, to make the API nicer to work with. And at some point, hooks came around. So obviously, I needed to add a hook, or actually I added 2 hooks, because people expect hooks to be the way to work with in React nowadays. So one of the problems that you quickly hit, that explains also the hooks versus component thing, is different users have different needs. So hooks is the primary interface now, so I needed to change that. That meant I had to update the documentation to focus on how you work with React Async using hooks. Some people like prop types, which is a thing in React that you can define the type definition of the component API. Some people use that, and others just don't care, and then they don't use it. Personally, I don't ever really use it in a project. But a lot of people want type definitions to TypeScript. So who's working with TypeScript? Anyone? Right, so a lot of people are using TypeScript. So everyone expects that there are type definitions for your library. Well, when I built React Async initially, it was written in JavaScript. Actually, it's still just JavaScript. It's not built in TypeScript. But it does have type definitions so that you can use it in TypeScript as if it's a TypeScript library. But that's not so trivial. Especially the fact that it's all about promises and async stuff. That's fairly complicated in some regard. Some people run your code also server-side or even in React Native. There's been people saying, oh, this works fabulously in React Native. I'm like, I didn't even do anything, but it just turns out that it works in React Native. Cool. But for server-side rendering, there's special things that you need to take into account, specific scenarios that you don't really take into account if you only do stuff for the client side. And then there's people who use Redux or MobX or Axios, you might know it, and they ask, like, how can I use this with this particular library that I happen to be using in my project? I mean, I really like React Async, but I'm also already using Axios. How can I combine the two? Well, the interop, it's usually doable. I mean, for React Async, I particularly chose promises as the one thing that it's all about. It's all just promises, and that's the boundary to the whole thing. From the get-go, I didn't go into doing like the fetch API. It does kind of do that now, but it's basically all around promises. So that's the level of abstraction that I chose to focus on, which really helps me a lot because like Axios also deals with promises, and a lot of the other libraries also. But still, you need to document how to do that. People are going to ask questions about how you do that. And then there's testing. So actually testing for an open, who's writing tests for their React applications or for their whatever applications at all? Good, good, quite nice. Not overly confident, by the way, so like, okay, we're kind of doing testing. Well, anyway, for open source projects, I mean, I guess you agree that when you're picking a library to use in your project, you're probably going to go look at the GitHub page of that project and see, are there any tests? Does this thing look credible at all? If there are no tests, you're probably like, okay, let's not bother with this because I don't trust this code to work in every scenario. So for open source projects, testing really is mandatory. It's a requirement, you just cannot get around it. So I'm really proud to say React Async has 100% test coverage. And I'm trying to keep it that way. Because users expect verification that stuff is always going to work. Some sort of quality control, like a quality gate, like when there's a new release, that old stuff is not going to be broken. In my particular example, this is by the way, as it is currently, all of the files in the project. This is the source directory. All there is, nothing more. So it's okay. You might argue that maybe you need subdirectories. Personally, I don't really care because for me this is manageable. So it started out with async.js, and I later on added like the use async, which is the hook, and there's some stuff in between that does stuff. But anyway, the thing here is that my tests, I always try to co-locate the tests with the source code. Co-locate means the tests for it are right beside the source code. Actually, co-location, if you go to the extreme, that would mean the test would actually be inside the same file. That's like what CSS in JS is kind of all about, like co-locating your styles with your JavaScript components. But that's a different discussion. So in this case, I chose to have the test right beside them, rather than having a tests directory in some other place and then mimicking copying the file structure. It's doable. I prefer this. And then very particular to this one project is that async and use async, they expose the exact same API. Because I already had the async component, but hooks, like the hook for it, actually does the exact same thing as the async component does. So they expose the same API. What makes it interesting is that means that I want to have the exact same tests for both of them. So that's actually what specs.js is all about. I mean, ooh, it's okay. So you probably know this by heart, but I don't think many people are actually doing this. If you have a spec file, tests file, you can actually import tests from other places. I mean, hardly anyone does that, but you can. So there's tests in here that are basically imported into this one and into this one, so that I can reuse tests in two places. So I write it in one place and I run it against both the hook and the component, because they expose the same API, so I can just do that. In fact, the way that it works, I'm not going to show it here, but the way that it works is that the spec for use async, actually in there, I'm just creating a new component called async, wrapping the use async hook, and then I'm going to run the tests against that mock component that I just created, which is exactly the same as async. So technically, I could have async basically use async underneath and do the same thing. But I don't want to, because hooks were introduced in React 16.3, and I want to have backwards compatibility. No, actually 16. Something else. 16. Don't remember. 16.8. 16.8. The hooks were introduced, and I want backwards compatibility towards 16.3, because that's what I initially had, and I want backwards compatibility for my component. So that's why, essentially, I re-implement the same business logic both here and there. And that's where this reducer comes in. Because essentially what I did was, there's a lot of business logic here, there's a lot of business logic here. I want to share that business logic also. So actually what I did is use a reducer, the reducer pattern. This is not Redux, by the way. This is just a reducer pattern to extract that business logic so I can reuse it over several places. Anyway, one important thing to note, this is especially true for React, but I guess also for other front-end frameworks, is you should always just test the component's API. So render the component with some props, as it is in React, pass in some arguments, and then you expect some sort of result. Don't test the inner workings. Like what you might be tempted to do is do things like, I expect that this inner function is going to be called at some point. But that means that your tests knows about implementation details of the class or the component, which, well, sometimes there's no other way around it, but in React, the whole idea is that you can avoid that, which makes your tests more stable over time, because implementation details tend to change over time. So like I already mentioned, some tests are shared between components and hooks. And this is really super important, is if you have pull requests coming in, you can obviously run these tests against the pull request completely automatically. And that saves me a ton of time. Because if someone's opening a pull request and the tests break, I can just go say, hey, go fix the tests first, because right now I'm not confident that your stuff is going to work. But I would say that also goes for a really big part for myself. Because what I do is when I'm building a new feature, is I'm actually opening a pull request against my own repository, and I will notice when the tests fail. So it's also a sanity check for myself. All right, so currently I'm working on this new feature. It's called the DevTools for React Async, React Async DevTools. It's still in pull request somewhere, so it's in a separate branch. But soon there's going to be a separate DevTools package. Actually, it looked like this. What the DevTools allows you to do is essentially pause HTTP requests in your application while you're developing it, so that you can test the spinner, the loading indicator screen, or whatever state that you have, or replay requests in development. which is something you cannot do through the Chrome DevTools. But what's important to note here is that I want my DevTools to be in the same repository. So I have one GitHub repo for the entire project, and I want the DevTools to be in the same repository, because if I'm going to put it in a separate repository, keeping these two things in sync is going to be much harder. This is a thing called a monorepo. It kind of looks like this. Instead of having a top-level source directory with your stuff underneath, you're going to have a packages directory with the two packages that I have. And under there is the source directory and a package.json and a Babel.rc and whatever. So that's what it's going to look like. Well, multiple packages in one repository, it's a tricky thing. Because not all the tools that are out there support monorepos properly. In particular, Babel. It requires that you use, instead of this Babel.rc file, it requires that you use a babel.config.js, because it treats that thing differently than a Babel.rc file. You can do the same thing inside, but if there is a babel.config.js, it will treat the directory where that file's in as the root of your project. While Babel.rc, it's actually recurses, I believe, up pretty much infinitely, which is annoying in certain situations. Or Babel will not know that when you're requiring a file, like importing a file from one package in another package, as I'm doing actually with this thing, inside React Async DevTools, at some point there's an import statement that imports React Async. So what I want to do is when I update something, change something in React Async, that I see that change in React Async DevTools. So that's why I need the monorepo for. Also, well, Storybook, I haven't told you anything about it yet, but I'm happy to use Storybook. Makes sense, right? I'm going to work for Chroma. And it requires some specific Webpack overrides, because Storybook uses Webpack internally with a default configuration, but it doesn't support monorepos out of the box. There's actually just one line of code that you need to change and to override it, and it'll work. But you need to figure that kind of stuff out. Actually, I just asked Norbert, like, how do we do it? We were actually on the plane to Los Angeles, and I was like, oh, let's do some coding. I mean, he was sitting right beside me, and he told me, like, I've been struggling with that thing for 2 weeks, and he just tells me, you're just gonna have to change this, override this config here, and it will work. And it worked. Like, sometimes just reaching out to the original author makes a lot of sense, right? That's the quickest way to do things. Another one is Jest. So Jest is this tool for running the tests, and it needs to know where to find your projects. So you need to configure Jest to know how that works. And probably you have some scripts in your package.json. Need to update those as well. And in my opinion, the most annoying thing about monorepos is nobody documents how you can ever use their project with monorepos, because they're so uncommon. Like, not a lot of projects are doing this yet, that the documentation is just non-existent most of the time. So you need to look into the source code, figure stuff out, sometimes open a pull request to make it work, and so that's the thing. So while React Async is mostly something that you don't see. It doesn't really render anything on screen, because React Async just deals with HTTP requests and such. But rendering something on screen, that's up to your application. But with these DevTools that I introduced, all of a sudden I'm exposing some sort of user interface. It's only for development purposes, but I expose some user interface. So when you're building visual components, something that components that render something on screen, as do most components, Storybook is a really awesome tool to help you build those components in isolation. In fact, for React Async, I didn't have a larger application within which I could build a component. I needed some sort of a framework, a sandbox, if you will, to where to render my component so that I could build it up visually. So that's why I needed Storybook actually in this scenario. But in general, Storybook is a tool that helps you build components in isolation, so outside the scope of your application, so you don't have to bother with doing HTTP requests waiting for some data to load before it can render your component, or clicking through your application to get it in a specific state and where it will render the component that you're building. So if you can build it in isolation, you don't have to bother with all that setup stuff. And then you can catalog all of the components that you have in your entire application and the various states that they can be in. So like a button has different variants, but also like a menu can be open and closed, for example. So you can in Storybook you specify this one state, but also the other state, all the various states actually, that your component can be in, so that you have an entire catalog of all the various components in their various states. It actually works with every major view layer. I happen to use React, but if you want to use Vue or Angular or whatever, Storybook can handle that. It's very popular. It's a really huge community. Actually, who's using Storybook already? Just a couple hands, not too many. I really need to change that. So this is basically what it looks like. You get this canvas. So this is the component that you are developing at the time. Here's like the catalog of all the stuff that you have in your application. You can have add-ons and panels and such to change the state of this thing with some knobs and log events and trigger actions and all that stuff. So that's what Storybook is about. This is a cool one. So at some point, I want to publish this component on NPM, right? So what people used to do, most of them still are, most projects still are, is use Babel to compile, transpile your ECMAScript 6 or ES 2018 code to ECMAScript 5 so that it would work in all the various browsers that are out there. Well, that works, but it's also very inefficient because the application that are using the application that uses such a project cannot optimize anything anymore. So that's kind of a downside. I mean, we want to move the web forward to newer, greater things and use all the new features that ECMAScript 2018 offers us, because browsers support that stuff nowadays, without any transpilation. So that's where Pack, or I prefer to just call it Pika, because Pack is too generic and nobody knows what you're talking about. So Pika Pack, whatever. It solves this problem. Essentially what it does, it takes your ECMAScript 2018 code or whatever, if you write it in TypeScript, fine. TypeScript also, and then transpile that code into multiple various flavors of JavaScript. So there's an ES5 version, there's one with ECMAScript modules, there's the original source code, there's the version for Node.js, because Node.js uses the common JS module system. So it's a lot about the module systems that are in use, basically. And then write out package.json with not just a main entry point. Main entry point is actually for Node.js, but it was abused for browsers as well. And then there is ESM or a modules thing and another one. Anyway, you don't really have to bother about that. Pack handles that for you. So it builds packages for these various environments, and then that's what you publish on NPM. So that when someone else is actually importing React Async, their Webpack configuration or rollup or whatever they are using, they will figure out, hey, this is ECMAScript 2018 code. That's cool. I'm just going to use the original source code rather than this mangled ECMAScript 5 flavor of it. So it's actually more efficient in that way, that it can optimize for particular build targets. And it's totally configurable with plugins. There's plugins for TypeScript definitions, for example, which is something I also use, pretty cool. So they will also ship with type definitions. And actually it just uses rollup under the hood. It's kind of like an alternative to Webpack. So that's back. So I'm going to list a couple of these tools that I use, which I think are cool. Another one is Lerna. Anyone heard of Lerna before? Nobody. So, ooh. Lerna is specifically targeted towards monorepos. So repositories with many packages in there. So what that does is, let's say you are building a component library for your company. You have a button components and form input field components and other kind of components, and then you have a header component which uses these other components. So it uses the button and the input field to render a search bar inside the header. So then you have a header component that relies on a button component. What you want is that when the button component is updated, you change the source code for the button component, that will also be reflected, automatically updated in the header component, so that you don't have to go and upgrade a version number, for example. So that's what Lerna does. Lerna is, I've used it in the past mostly for component libraries, such as this one particular example. But also I'm using it for React Async. And what it also will do is when you publish a new version of one particular component, it will ask you, what it will do is it will detect changes in your Git repository to automatically detect which components have been updated. And then for each of those, it will ask you, is this a major, a minor, or a patch version upgrade? And you pick one. Let's say it's a patch version because it's a minor bug fix. It will bump the version number in a package.json, but it will also update all of the dependent packages that use that particular component to bump the version number in that file as well, and then publish those as well, obviously. So all of that management surrounding version numbers and all that stuff, that's what Lerna does. Then it can publish that to NPM and create commits for Git, like we bumped the version number, and create a tag, a Git tag, so that you also see it on GitHub under versions. This one, who knows Michel Weststraten? Just one, all right. Michel Weststraat is actually a guy from Rotterdam, I think. What? He's actually, yeah, he's from Mendix. Well, he used to be with Mendix. He's a freelancer now, I think. But actually, no, I'm not sure if I can already tell you that. I have some inside information that I cannot share. So Michel was or is a freelancer. He created a thing called MobX. It's a pretty popular library in the React community, like it's huge. Anyway, this guy is pretty smart, and now he created this thing called relative depths, which solves one particular issue that you have in when you're creating a monorepo. Actually, what I'm going to switch to the actual project here. So let's take a look at React Async on GitHub. So it's right there, and you see I have an examples directory, which is a common thing to have an examples directory. So I built this component, and people want to know, okay, how can I use that thing with some basic examples with fetch or as the hook, but also with like Next.js, for example. People are using Next.js, a framework for React, for server-side rendering, and I want to know how to use that with Next.js, for example. But the thing is, each of these things, they actually depend on React Async. And I just say, okay, we depend on the latest version of it. But that means that I need to manually to actually publish a new version of React Async on npm, and then run npm install in the examples directory before the actual example will be using the latest version of React Async. But sometimes, or actually oftentimes, what I want to do is update each of my examples with the very latest development alpha version of React Async, so that I can test that this example does not break with the changes that I made to React Async. So that's what actually this relative depth thing by Michel is about. So what that allows you to do is have a thing called relative dependencies in your package.json, which basically point to a file somewhere. So ///packages and then React Async in my case. Which is something that's not supported out of the box by npm or yarn or whatever. So that's the problem that he solved with this library. Well, this thing, as you can see, it was released 2 days ago. So I have not gone to the point yet where I can update my examples to actually use this, but I will when I get around to it. But there's quite a lot of stuff happening in this space. It's kind of unexplored territory in some regard, but I think it's where we have to go as a community. So a thing about version numbers. Version numbers are important. It's not something to overlook when you're bumping this new version. There's a reason that Lerna will ask you, is this a major, or minor, or a patch release? Because people use version ranges, and when I say, okay, this is a patch release, well, there's actually a breaking change in there, people are gonna all of a sudden end up with a broken application, and they will not see it on their local machine because they already have this thing installed locally, the older version of it, but their CI pipeline or wherever, or in production even, it will break. Because all of a sudden they get a newer version because they're using a version range. So say 1.2.x, anything goes. If that thing is a breaking change, then their application is going to break. So that's something to take into account. So always, if there's a breaking change, and there's a lot of things that can be a breaking change, by the way, even in certain situations, it's probably a breaking change, then it has to be a major version upgrade. It's very tempting to avoid doing a major version upgrade unless you have really something big to release, like only if the entire component has basically changed. But really, regardless of the size of your change, if it's breaking, it's breaking. So it has to be a major version upgrade. Sometimes I really don't like that I have to do like, oh, we're now going from number 6 to version 6 to version 7, even though really basically nothing has changed, not a lot has changed. So what I tend to do is group bunch of changes together and then do a major release. But basically, in essence, I try to always be backwards compatible, which is why sometimes I choose to do something a little less efficient, but at least it will be backwards compatible. This is a nice ezelsbruggetje, if you will, for when to do what. So if it's a breaking change, it's a major version upgrade. If it's a new feature that you've added, it's a minor version upgrade. And if it's only a fix for some bug, and really sometimes, then it's a patch version. But oftentimes, a fix can actually be a breaking change. So that's the tricky area somewhere there. This is basically Semver. I'll share the slides on the meetup page, so you can come back and look at it if you want. Right, so last but not least, documentation. So people expect to, if they're considering using your library, they expect there to be some sort of documentation. So some people like to have like a website for their project. A lot of projects do, and that can be cool, but the downside of custom websites is that they're custom. So every project has a completely different website, and you have to really learn again how to read this documentation, because people structure things differently. You can find them different. Navigation's different with each of them. Well, GitHub has already solved this. I mean, just put it in readme.md. It's a perfect place, really, for documentation. And it's really quite flexible. So just start with the getting started information. Makes sense, right? That's the first thing. Like if you're serious about your project, you want to get some adoption going, so people need to be onboarded into getting started with your project. That's why you always see, like, okay, do the first step is npm install whatever library. Actually, even though you've done it 1,000 times, it's still easy to be able to copy and paste that. You know these badges? Probably you've seen them a lot. There's these badges on projects, on the README files. These things that take a while to load. Code coverage is broken for some reason. Anyway. So now it's there. These badges, they're there for a reason, but they also just basically make your project credible, right? If you see a README that looks like this, like, that looks like a professionally done project. It's got a logo with a tagline and then a whole bunch of mostly green badges. That looks good. So yeah, they serve a purpose. But also for me, it's useful for me personally to look at how many downloads it gets a month. If my size is not really through the roof, because a lot of people care about that nowadays. If the build's still passing, although nowadays it will also show up here. If the build is passing, oops. Code coverage, license, people care about licenses. MIT, ISC, whatever, they're all open source. And then, well, there's issues and pull requests. Whether or not that's a good or a bad thing, depends on the project. I don't care about 10. Actually, personally, my rule of thumb is there can never be more than one page. But let's see how long that holds up, I don't know. But as you see, a lot of them are opened by myself. So I open a lot of issues myself, just like, this is a to-do that I want to do someday. And apparently there's no IE11 support. To be honest, I don't really care about that one, but so that's that. Copy and paste material, really useful. I go to my own README file all the time and copy and paste stuff from that README file. And I'm basically helping myself. That helping myself goes for the README, but also for the tests, for a really large part. Because I make mistakes. I make mistakes all the time. And having a sanity check on my own mistakes, that really helps to fix your own mistakes. That's why, for example, all these example projects are very important, that they are constantly updated with a new version, because oftentimes oftentimes I release a new feature, but if I want to release a new feature, but I've basically overlooked one particular use case, let's say Next.js, for example, and it breaks in Next.js, and I'm going to have to go and figure out how to fix that. Well, if I didn't have all these examples, I would have no way to know, really. Right. So that's my talk for today. This is me. You can look me up at Gert Hengeveld on Twitter and whatever, GitHub. Thanks for listening. Don't know if there's time for questions. Any? I can imagine it was a lot of information to take in.
What testing library do you use?
So yeah, I'm using Jest with React testing library. It's particular for React, but although Jest is basically a test runner, which is quite common also outside React, I believe. React testing library, actually, let me show you. Something I neglected to tell you. So React testing library, this one, it was built by this guy called Kent C. Dodds. He's quite famous, at least in the React community or in the front-end development community. He has his entire website about how to do testing properly. That's also where this notion comes from you should be testing your components API and not the inner workings. He's a big proponent of that approach. And that's basically also what React testing library is all about. It makes it very easy to test your component API and makes it pretty hard to test inner workings. It's still possible, but he actively discourages doing that. So that's React testing library. But there's also nowadays, you should be aware, there's actually now testing library for a bunch of other things. So let me check. I think it's there for React, Cypress, Testcafe, I don't even know. That's Svelte, Vue, Angular, Reason, React Native, a bunch of other stuff. Cool project. Any more questions?
Did you consider a lot of other options for the model repo, like Git submodules or stuff like that?
I didn't try Git submodules, mostly because I have never ever seen any project do that approach. So I'm pretty sure that I would not be able to pull it off with Git submodules. I think it's just not in some way suitable for the problem that we have. There is one alternative approach, which is actually something that I am kind of using. It's Yarn workspaces. So most of you will know NPM. There's also Yarn, which is an alternative command line interface to NPM. So Yarn is, it's basically NPM with some additional features, and apparently it's faster. But there's this particular thing called Yarn workspaces, which is also still a bit unexplored territory. But workspaces, it's a new way to set up your package architecture. But essentially, it allows you to have multiple workspaces or packages inside one Yarn project. So actually what I'm doing in React Async with my DevTools branch is I have both Yarn workspaces and Lerna and Pack, which does complicate things sometimes, but Yarn workspaces basically looks like this. In your package.json, you have a workspaces key, and it defines where to find all the packages. And in this case, I just say everything under /packages. Makes sense, right? And then from there, Yarn allows you to run scripts in all the packages, for example, but I already use Lerna for that. So You see Lerna, for example, Lerna exec yarn test basically says, hey Lerna, go run yarn tests in each of these packages, in all the packages that I have. So that's the way that you automate tasks, basically. So when I run yarn test or npm test in the root, it will run it in all of the packages. I hope that answers the question. Ja.
Oké, nou, dankjewel Gert.
You're welcome.
Gaan we even een kwartiertje pauze houden. En gaan we daarna verder met Pieter. Ja? Dus pak lekker wat te drinken.
Is nog ruim?
Ja.
Ja.
Oh,
Super.
Is best.
Ja, voor de klikker.
Toch wel.
Ik hoop dat ik er niet al te veel kwijt ben geraakt onderweg.
Nee, dat kan ik moeilijk inschatten. Veel nieuwe gezichten hebben voor mij. Maar dat gaan we altijd daarna. Zag je een beetje aan de gezichten?
Volgens mij staat er veel werk aan de kant. Oh, er waren wel veel TypeScript developers waren trouwens. De helft was TypeScript ongeveer.
Ja, ik ben eerst daar dat waren hartstikke veel. Maar voor mij is het voor mijn team zijn er nee, maar er zijn heel veel voor mijn team. Ik weet niet wat het is. zetten. Maar hij pakt het heel goed op.
Oh, oké. Nee joh.
Kun je rest van in de zak doen?
Ja.
Staat hij aan?
Hij geeft een rood lichtje? Ja.
Oké, dames en heren. Tweede spreker. Pieter gaat van start. Veel succes.
Dankjewel.
En veel plezier.
Ja, goedenavond allemaal. Mijn naam is Pieter van Dorst. Ik ben Full-stack JavaScript Developer bij Passionate People. Ja, een aantal jaar geleden werkte ik bij ING, een jaartje of 3 geleden. Dat was volledig AngularJS op dat moment. Dus alle frontends die zij op dat moment bouwden, waren gebouwd met AngularJS. Alleen ze kwamen erachter, nou ja, AngularJS was al end of life. Dat stopte ermee, het was ook niet performant genoeg meer. Zij moesten over gaan stappen naar iets nieuws. En ze hebben op dat moment de keuze gemaakt om op webcomponents te duiken in de vorm van Polymer. En eigenlijk een hele frontend, alle frontends die ING bouwt en gebruikt, op basis van webcomponents op te gaan zetten. Daar was ik dus ook bij betrokken op dat moment. Nou, ik was vooral op dat moment toen ik daar binnenkwam en daarmee begon. En ik heb zelf ook toen veel applicaties kunnen bouwen met Polymer. Daar was ik best wel sceptisch. Webcomponents waren toen niet al te best gesupport. Er waren heel weinig browsers waarmee je überhaupt iets met webcomponents kon doen. De performance was vrij slecht. Vooral op browsers als Internet Explorer was het echt dramatisch op sommige momenten. Oh wait, I should talk in English, right? Yeah. Sorry, it's natural. Yeah, it was pretty dramatic to work with Polymer or to work with web components in that age. Also the tooling around it. The only real library which was building with Polymer, which allowed you to build web components or to build apps with web components, was Polymer. The tooling was pretty crappy, especially if you wanted to do integration testing or unit testing. It was quite a lot of work. So I was not too happy with it when I was working at it at that point. I did see the potential of it because I think it's really strong, and I hope to share some of that with you tonight as well. But yeah, it had a lot of flaws. So then I left ING like a year and a half ago. I started doing other things. I did a lot of React lately. And then, like, beginning of this year, I think it was, I started looking a bit at web components again, just because I was curious, because there was a lot of things happening in that area. And what I saw was that it got mature a lot. Yeah, it matured a lot in that little time, in like 1 year, 2 years. So what I saw was that you no longer have to fear that browsers don't support it, because all the major browsers now suddenly support web components natively. There are a lot of new frameworks around it, a lot of new tooling around it, which allow you to really make the best out of web components. And just the overall culture or the overall system around web components has matured a lot, which is what really surprised me in a good way, and which is what led me to come up with this talk and to hopefully spread the word about web components a bit in the community. Because I think nowadays it's really a new, powerful tool for all web developers out there in our toolbox to help us build better web apps, basically. So a little bit of history. When we normally build a web app, especially like a few years ago, it will look like this. So we have an application which is like one big CSS file, one big HTML file, a bunch of JavaScript, and that is a website, basically. In the past, this was very clear because you had no frameworks like Vue or Angular or React, which allowed you to make components out of things and to really pull things apart. You just had to do it this way. Well, then we got these frameworks because we found out that if you want to build like a simple website or a simple web app, this works. But once you start adding complexity and building real applications with more complex logic, then this will become a management problem really soon and will be really hard to manage as a developer. So we got these frameworks like Angular, like Vue, like React, which try to mimic this way, basically. So we're no longer building one big thing. We're building little blocks, and we're putting them together, and that makes it a lot easier for us to manage them. But under the hood, we're basically still doing this, because React and Vue and Angular, they all translate the stuff that we put in, the components that we put in, to this thing. Like, yeah, everything is related to each other. So if I, for example, create a class in a React component in one place, then it will also affect some other component 3 miles away. So this is never really achieved. And what Web Components does, or what the Web Component specification does, is it makes this way of developing possible in a native way. So without frameworks, without React, without Vue, you can create separate blocks of functionality, components, with their own HTML, own JavaScript, own CSS, fully encapsulated. So that means that everything that's in here stays in there and doesn't go out and affect other parts of the application. So it basically allows you what the frameworks allow us to do. It allows you to create components which are standalone and which can be reused throughout your application or other applications, basically. Well, web components, they were first introduced in 2011. That's when people started talking about it. And it took till about 2015, I think. That's when the first version of Polymer was released, which is by Google, owned by Google, by the way. When it really started getting track, which was mainly because of Google, because Google was really pushing web component, the web component specifications through Polymer to basically get the other browsers, because I think in 2015 already they implemented all the features in Chrome, because they wanted web components to work, and they wanted them to work everywhere. So they really started pushing it and getting the other browsers involved and getting it in Firefox and in IE and in Edge, that kind of stuff. That was 2015, and yeah, that's when it came, and that was version 1. Polymer is nowadays, it's end of life. They stopped developing it because all the browsers now support these features, and because Polymer is basically no longer needed, as they say. But let's go a bit back. What is a web component then exactly? If you're familiar with Docker, for the back-end side of things, a Docker is like a shipping container for applications, which supplies you with a common interface. So like one common way of how something looks and how something measures to build your applications or to build the things you use. Web components are the same thing, but for web development. So it gives us a common interface, which is known by all browsers. All the browsers understand it, to build components. So everything that's under that interface, which is inside that component, that's up to you. You can do whatever you want in there. But the interface is always the same. So you have one component with a common interface, which you can use everywhere, in every browser, natively, without libraries, without JavaScript. They just understand it. Well, that web component specification, that consists of 4 parts, basically. So to build a web component, you need 4 separate things, which are the 4 specifications, which are implemented by the browsers, which allow you to do these things. Well, the first one, that's custom elements. Ever since we started working with HTML, we have used HTML tags, basically. So you have tables, you have divs, you have videos, you have buttons, all that kind of things. That's natively implemented. You can just use them. We've always done that. But something that was never possible is to create your own tags and your own HTML elements. We can mimic it. If you use React, we create tags, but these are not HTML tags. These are like, that's just JavaScript-powered tags. Put it like that. But what custom elements does, it allows you to define your own HTML elements. So I can create something like my button or awesome table or whatever I want, basically. So if you go in your browser, every browser nowadays, the new ones, have this command, custom elements.define, which takes a name, which is like the tag you want to use, and an element, which is the HTML element you want to expose. It's basically a class, an ES6 class. The second part of that specification are HTML templates, which is like a template tag. When we usually have HTML, and we send it to the browser, it's rendered immediately. So we have like a script in HTML, and I load that in the browser, then the script will run immediately. What HTML template does, it allows you to create basically templates of HTML, which is just plain HTML, but it's not run immediately when it hits the browser. It waits for a command, like I think it's a clone or something, it's native stuff, before it actually starts doing anything. And what this allows us to do is to basically, as it's depicted here, stamp pieces of HTML into our app. So we have the HTML and we can reuse that in multiple places and it will keep, we can use it as a template, basically. The third one, so I think the most important one, is the shadow DOM. The shadow DOM specification is what allows us to fully encapsulate the things we're building. So we have a component, when we have a normal website, when I put a CSS class somewhere, it will affect the entire website everywhere. There's no way to stop that. Shadow DOM basically stops that behavior. So we have a regular DOM, the page DOM, which has all these children. So this is your web DOM. When I create a shadow DOM, I basically create a separate entity, a separate DOM next to my own DOM. And everything that's under there, that's standalone. So everything that I put in here, in JavaScript or in CSS, it only affects this part of my application, and this part is no longer affected, which means, it gives us full encapsulation of the logic and of the CSS that's in there. We no longer have to worry about it leaking out, basically. And then the fourth one to put it together is the ES modules. We never had a module system in our browser systems. ES modules provide us that. So it allows us to import script as a module into our web app, which makes sure that it's only run once, for example, and it allows us to export things. If you use Node.js, for example, you can export variables. In React, you can do it as well, by the way. It allows you to export variables, export things from files, and use them in your application, basically the same way you use in React, but then natively in the browser. And if you put all these together, so all these four, so you have the module to import your components, use them in multiple places throughout your app without them loading multiple times, that kind of stuff. You have the HTML templates to take care of your HTML so that it gets stamped into each component of each place where you want to render your component. You have the shadow DOM to make sure that it's all encapsulated, it's all in one place. And you have the custom elements to assign it to an HTML tag, which you can then actually use in your application. So it's these four standard specs that allow you to build these components fully natively without libraries and use them in your apps and in your browser. When we look at the web component, it has a lot of things that we already know also from frameworks, from the components we use. There's life cycle, so it has like when it's mounted, you get a life cycle event. You have a constructor, you have all that kind of stuff. You can have properties, attributes. It can have slotted content, which means you can put HTML into it, same as we do with React. And it has events, so it allows you to send out custom events, allows you to react to events. It's basically everything you need to manage a component is supported by default. So let's have a look at a native web component. So this is like the most basic component out there. So you see immediately the first line, custom elements been defined. So that's the first thing you do. Custom elements been defined, the name of your element, and a class. And the element has to be a class, ES6 class, and it has to extend HTML element. So we extend the native HTML element. It has all the stuff that we know. It has a constructor where you can do things. These are the lifecycle events, so it has a connected callback. So when it's mounted, you get the connected callback. If you look in here, for example, I can set variables, so I can say this count is 0. I can use that. I initiate my shadow DOM in this place, which basically does the attach shadow, which says create a new shadow DOM for me and bind it. And I set the inner HTML to this point template, which is my HTML template, which is all the way down here, which is just a bunch of HTML and style. This does not look very good, as in a way how you want to develop things, but this is how it goes, how you can create these components fully natively without any libraries, without any custom code whatsoever. So with the connected callback, we can also observe for attributes. What it basically does is we have an attribute changed callback. We can do some little loop in there, and then we can say if the attribute on my component, so if I have a label attribute on my component, if that's changed, then I can do something with it. So in this case, I can say this.label.inner HTML is new value. Well, what is label? Label is just a query selector to the shadow root with a .label. So what you can see here, there's no data binding in native web components. That's something that's not part of the specification. So if you need that, you have to do that yourself if you go full natively. So I just have the class here, class label, and I select that basically. You can add event listeners. It's it's pretty basic. It's pretty verbose as well, but it works, and you don't need anything for it, which is, in my opinion, the most interesting part. So yeah, you need no dependencies. There's no JavaScript in there. It's just, oh wait, I can still show you the example, by the way, because I didn't show that yet. So this is how it comes out, basically. So this is the component, and it has some logic so that it can actually count. I can also dive into it a bit. It might be interesting. So if I look at my component, I think it's in here, yeah. So you see the my counter element. So it's my own HTML tag which I created. There's a label attribute, my counter. And if I dive into it, I can see that it has a shadow root. So that is my shadow DOM. So everything in here is fully encapsulated, and there's the stuff that I actually put in it. So yeah, you can create your own element. You can put in it whatever you want, and everything that's in here is encapsulated. And this is like the global interface that works everywhere, to put it like that. So you need no dependencies. It's all native, nothing needed. And because you need nothing, no dependencies, it's very fast. If you build all your components this way, it will be really hard to manage, but it will be very fast. And because you don't need any libraries, it just works everywhere, as long as you're on modern browsers, that is, of course. But yeah, it's very verbose. If you build all your apps this way, if you would build all your components using native web components, yeah, I don't think you'll enjoy it, but it's doable, yeah. So let's jump over. So this is where React comes in. React is, as we know, it's a web framework. It's backed by Facebook. And it basically allows us to sync the DOM with data. I think that's its main purpose, to make sure that our data is connected to the DOM and that it stays in sync and that we can build complex applications with it. It's component driven. Component already comes back. And there's a lot of advanced tooling around it to build more complex data-driven application in a way that's actually manageable and fast. So where do these two meet? Yeah, let's start at what React team itself has to say. They have a little description or a little comment about web components on their own website, which start like this: React and web components are built to solve different problems. Yeah, I think that's true. Web components provide strong encapsulation for reusable components, while React provides a declarative library that keeps the DOM in sync with your data. Yeah, I think what that basically means is that web components allows us to build the components, and React allows us to use these components to keep everything in sync. So to do the actual collaboration between these components to manage that and to make that manageable for us as developers. The two goals are complementary. So what they're saying is the two should be able to work together. So that's a good thing. I think if you look at the second line, we're not fully there yet, as you'll see in a minute. I'm going to show you how to work with React and how to work together with web components, but it's not perfect yet. We'll see that. But I think this is pretty much the end goal that we are striving to. So to use React or use your library as the glue between your components and to management between your components and to basically build your applications and to use the web components for the actual component stuff. So the smallest part of your application, basically. So if you look at where they meet, they can meet basically in two places. One place is that we have a React application, and we would like to use web components written in any other language or in React or whatever inside our React application. So we want to use existing web components. The second scenario is where we have another web application. It doesn't have to be React, it can be anything else. And we want to have, like a big library of React components. We want to reuse those, so we want to turn those into web components and use them in other places. So that's about the two scenarios you can get. Let's start by looking at the first one. So let's say we have a React app. There's a website called customelementseverywhere.com, which basically tracks which libraries support the use of web components in the best way. So which libraries make it the easiest to use web components in them. Well, you see that React is pretty low, score 71. I think it's the lowest score on the entire board. And we'll see why that is in a minute. React is pretty good already. But it basically means that it's a bit harder to use web components in your React application. And that's mainly because of these two reasons. The data binding. I think what React does, it passes everything on to your component as an attribute and as a string attribute. So when you try to pass, for example, an object into your web component from a React app, it will just pass like a string object, which it can't use, so it will break things. So you have to do manual stuff to get your more complex data into your web components. And the second thing is the events versus callback thing. React is heavily using callbacks. It doesn't support native events from the browser, or at least not. You can't listen from your components. So what this means is that you cannot simply add an on some event name, do some action on your web component from your React app, which means you have to very verbosely grab your components, say add event listener, the native browser functionality, and add your event listeners there. We'll see it in a minute. But these are the main two things that makes it a lot more cumbersome to use web components in React. I have a little project for that. Let's have a look. So I have a little React project built. It's like a create React app, so it's the most simple one, nothing in it, basically. It has an app.js. So I have one component, app, does some basic stuff. And what I added in here are these three things. Vadin is a company. I don't know where they're from, somewhere from Finland, I think. I'm not sure. Who build a lot of web components. And they expose these web components to the community and allowed us to use them, basically. So I imported 3 of their components, a button, a text field, and a time picker. I think these are written in Polymer or something. Polymer 2, I think. I'm not entirely sure. But I can just import these in my app. So it's just a dependency of my application. I have my app, I have my render, and in that render function, I can use these web components. That part works. So as you can see, I have the Vadin text field, which is a web component. So this is an existing web component. I can add values to it. So I said the value is first name, the label is something. It has some other options I can give. So these are like, this is the interface of the component which I can use. I have the button, I have the date picker. Let's first look at how this works. So yeah, I have like a simple form. It has some styling in there, it has some functionality. So I have like this cross thing This is all part of the component, so I haven't done anything for it. I just imported it and I put it in and it just works. I can add this a date time picker. I can pick times. It's just, yeah, part of the component, basically. So that part, just rendering it is fine. That works perfectly well with React. It knows how to deal with web components, so that it just renders. That's fine. But when you start having to do things with it, then it becomes a bit more complex. As you see, I already assigned some refs to it. That's because this text field that throws events, the web components make use of events. They don't use callbacks usually. It throws an event when it's changed something. And the only way to listen to that is to add a ref to it, like this. And to, I think it's here, add event listener to it manually. In this case, component in mount, first name field, current, add event listener change, and then do the logic I actually want to do. So in this case, I add that value from that field to my state so I can manage it, so I have my data binding working. Which I have to do for each field. So I have to do all these refs and all these data bindings. And this is the cumbersome part. This is why it's on 71% and why it's not fully supported, because things like this require a lot of manual work, basically. Same for the button, so I have to submit. Well, then it just works, but you can do things with it. So it's not that bad, but yeah, it requires some manual labor that you generally don't really want, especially if you would like to use a lot of them, then yeah, this becomes not so fun. But apart from that, yeah, it renders, it works, it's native stuff. If you look at the other side of the table, if you look at, we have React components, we have like a library of React components. We might want to start using some other framework, but yeah, it's really wasteful to just throw all these components away and to start doing everything over again, as we're sometimes used to, but it would be a lot better for us if we could just reuse these components in our new environment or reuse them, yeah, wherever we want. And that's also possible. There's a bunch of different ways to do that. Yeah, in good React fashion, there's, I think, 10 different libraries which allow you to transform your React component, or to transform your React component into a web component via a proxy, per se. So you put something around your React component which matches the stuff inside your component. So your callbacks and your attributes and your props, it matches those to a common web component interface so that you can use your component as a web component in your system. Well, how does that look? I have a simple app. It has an index.html. Well, what you see first is that I import React and React DOM at the top of my HTML file. So this is the native HTML file. And I also import my button.js, which is my web component built with React, which I'm importing. What I could do is package React and React DOM inside of my button element, but then every element I have would have the entire React library inside it, so you would have components of over 100 KB. So you don't really want that. So I just pull them out, and this is just my component, and it expects there to be React in my browser. So there's a bit of a dependency from my component on my environment, which is not too good, but yeah, there's no way around it. You need React if you want to do it that way. I import it, and then I can just use it. Now the name is wrong, but yeah. My counter, it can have props, it can have a limit ID, that kind of stuff. If I look at the component itself, yeah, it's just a component. It has stuff in it. What's in it is not really that interesting, I think. It just, yeah, it counts. And then the interesting part is this. I have a register function, which is coming from one of the from wrap React components, which is one of the libraries which allows you to wrap a React component to make it into a web component. So I have the register function. I add in my element, so my counter in this case. I give it a name, my counter. I specify which attributes, which properties I want to have on that element. So in this case, I want to have a label, a limit, and an is disabled, which are mapped to the properties on my React element, basically. And I also transform my callbacks, in this case on target, so my React callback, into a custom event, so an event that is thrown when that callback is fired. Because web components use events, not callbacks, so it transforms that into a custom event target, basically, which, other things using my web component can understand. So this is my component. So use it in here. I can add event listener to it with that event that I specified, target, and I can do things with it, basically. So I have a React component. It's just a plain React component wrapped into a web component. So yeah, I can run this a bit further, and then at some point when it reaches the limits, it will give an alert. But yeah, it's not a lot of work, as you can see. It's quite easy to get your React component working as a web component, but it does need, you do need to add in the libraries, the React libraries, React DOM libraries into your app to make this work. So if you were to like use 10 different web components in your app, and some are React, and some are Vue, and some are whatever, you probably need to import all these libraries into your app, which is not really something you want, because then you have 4 different libraries into your app. So it's something to think about. But if you're in the scenario where you have a lot of React components, you're switching to Vue or whatever, then this becomes interesting, because then it allows you to, you need to add React in there, but if it's only React, it's manageable, and you can still reuse all these components which you already have, which you would otherwise throw away probably, in your app. And maybe migrate them later, but that's up to you, basically. It gives you a lot of freedom. That's what I'm trying to say. So why would you want to do this? Yeah, it allows you to use components everywhere. It reduces the vendor lock-in. When you have everything built on React, it's quite hard, or everything built on Angular or whatever. It's really hard to think about something else and move to some other framework, because it's really expensive. And this makes it a lot easier to actually consider that. If there are more benefits to switching, or if another framework better fits some other use case that you're trying to build, then web components can really help you make use of the functionality that's already there without having to actually use the framework that it's built on, basically. And it gives you access to a growing library of existing components. There's a lot of components already built. Most of them are Polymer. But you can reuse those in your apps, wherever you want. And the library is growing. It's just an open source library, and they work everywhere. So why would you not want to use it? If you're aiming to support older browsers, and that's like pre-IE11, then using web components will be quite painful. There are polyfills to make it work, but the performance is not that great, so I wouldn't consider it, basically. You have some library overhead, because these native web you can write native web components, as I showed you, but the experience is not that great. So you will probably use some library to make it easier to write these things. If you're doing React or Vue, then it will be quite a big overhead that you're getting. And that is something to consider. If you're using 5 different web components from 5 different libraries, you'll get a lot of overhead. So it makes it more difficult. Another interesting part is integration testing. We're used to working with scripts that click through your browser and click on buttons to integration test, to test if our code is working as expected. Because web components use Shadow DOM, which is encapsulated, that no longer works, because you can't come into that Shadow DOM because it's encapsulated, which makes it a little bit harder to do integration testing the way we used to. I haven't seen a really good solution for this yet. I'm not sure, maybe there's new ideas about it nowadays. The last time I checked, they were still fighting over how to deal with this issue. But then it's a bit of a drawback to working with web components, especially on a large scale. And it adds complexity. everything you add, every new idea you add to a project, that makes your project more complex. So it's really important to think about if that complexity weighs up to the value it adds to your application, to the project you're working on. So yeah, it's always a give and take. So yeah, if you use React, it's over 100 KB. If you use Preact, it's like 16 KB, so that would be an improvement. So if you look a bit at the future, as I said, there's a lot of libraries already like fully focused on web components. We have lit HTML, which is like the new thing after Polymer that's released. You have Stencil, you have Sketch.js, I think that is. And if you look at the browser support, yeah, Edge is still doing something, I think. I think they already have it now. Yeah, they have it because they're switching to the Chromium engine for JavaScript. So basically all major browsers have full support for web components. So that just works. There used to be a lot of chaos in the sense that we're building everything on frameworks. Every developer has its own framework. Frameworks switch around every 6 months, although that is slowing down, I think. With things like web component, things are also coming in our dynamic imports and web packaging, which is like native ways to package your application, to dynamically import stuff in your application. The trend that I see from this is that we're going to order in the way that things are more and more heading to the browser. So instead of that we've tried to solve everything with JavaScript libraries and JavaScript frameworks, we use the browser for it. And like the overlaying stuff, because there's stuff that's never coming into browsers, that is what we use the libraries and the frameworks for. So what I think will happen, things like Webpack, for example, yeah, you won't really need that anymore. For one, because all browsers support the same things, so you don't need to transpile stuff and to transpile stuff down and to implement dynamic imports and to, yeah, all that kind of things. And I think frameworks will be more and more like the managing agent, so the thing that manages your component, and not the thing that actually implements your components, because that's what web components are for, basically. So the role of these libraries and these frameworks will tone down, I think. So yeah, a bit of a recap. Yeah, as far as I consider, web components have reached maturity, supported everywhere. As you could see, React doesn't have the best integration with it yet, but I do think if you look at other frameworks, Vue and Angular, it works seamlessly, basically. So I do think, or at least I hope, that React will follow that same way and make it a lot easier to actually use these web components without a lot of boilerplate. It's not the holy grail of web development. It only takes part of your component, bit, basically. And it's really important to think about the use case if it will benefit your project enough to, yeah, to add it in. But that's with everything you do, basically. Yeah, that's it. Thank you very much. Are there any questions out there? Is there time for questions? Any questions out there? No? That's clear.
Presentje. Het is geen klein presentje, het is een groot presentje, maar niet heel veel bierpakket van de Kaapse Brouwers. We houden het speciaal weer.
Ja, ik denk dat het een video, maar...
Oh, nou ja, zeker. Dankjewel weer. Fijn dat jullie hebben gekomen. Jullie nog een aantal nogmaals. Wij hebben een fijne zomerstop. Dat betekent dat wij de komende maanden juni een steektijd organiseren. Als je september weer de volgende, gaat Michiel ook. Die gaat over continuous delivery praten. Ik hoop dat jullie allemaal weer aanwezig kunnen zijn dan. Deze Tech Talk is altijd terug te vinden op onze livestream, livestream.developers.nl, op ons YouTube-kanaal als je nog even wilt terugkijken. Als je een vraag hebt, wat dan ook, kun je nog even de heren stellen. Ik denk zo eventjes zijn. We hebben nog nootjes, een biertje en we dat nog even rond. Dus blijf nog verder. Dankjewel.
heb je het wel eens echt gedaan? We hebben gewoon eens in de leven gewerkt. Ik wist het wel een direct, maar het klinkt inderdaad echt zo van... Ja, het is leuk dat het kan, dat soort kan, maar ik zie echt niemand echt.